Okay, moving on here with chapter 1. We just talked about using equalities and how we want to move into using them in solving problems. So I have a couple examples here, and what I want you to keep in mind as we look at these examples, these are not meant to be super challenging problems. I think these are problems that most of you could figure out how to do pretty easily without having to put a lot of thought into the whys of how the problem works. That, however, is not what I'm going for here with these problems. What I really want to do here is show you this technique of using units, because this technique is going to be something we can apply when we aren't as familiar with the conversions that we're doing as we are maybe with minutes and seconds in this case. So how we set up these problems is the important take-home message from some of what we're describing here. So we want to make equalities into conversion factors. When I say a conversion factor, I mean a fraction, and that fraction is going to have one unit on top in the numerator and another unit on the bottom in the denominator, and any equality can be made into two different conversion factors. So for example, with 1 minute is equal to 60 seconds as our equality, we can make two conversion factors. One where we put minute on top, so 1 minute on top, 60 seconds on the bottom. I'm using MIN here and SEC as the abbreviations for minute and second. And then since that's the same quantity, those are equal, that's equal to 1. But what would also be equal to 1 is if I put the 60 seconds portion of this unit on top and the 1 minute portion on the bottom. And that means this set of information can be used two different ways, depending on how our units need to cancel out when we're looking at doing a problem. So I've got two examples here of how to do this. So let's go through those two examples, and I'll try to point out what I mean here. In the first example, we're trying to calculate how many seconds are in a quantity of time equal to 12.4 minutes. So a good idea is always to take whatever data you're given in a problem. That's usually how you need to start any calculation. And what I want us to focus on here is the units involved in the problem. If we start with minutes here, before we can get to the quantity we're looking for in the problem, which is seconds, we need to get rid of minutes. So since minutes appears here on top of the fraction, I want to put minutes here on the bottom of the fraction because I want minutes to cancel out. Now, if I can introduce the unit that I want for my answer, which is seconds, I just need to put in the right relationship between those two here in this second step of my problem. Now, back up here, we see a factor that has minutes on the bottom. It also has 60 seconds on top. So I want to put that conversion factor here in my problem. That would allow me to cancel out minutes, and it would introduce a new unit, in this case seconds. Well, that's the unit we want for our answer. So if I just stop right there and then I do the math that's shown, I will get my answer, which is seconds. So if I take 12.4 minutes and I multiply by 60, and I gotta find my calculator to do some of these calculations. Sorry about that. Got my calculator. If I take 12.4, whoops, 12.4, and I multiply by 60, right, the answer is 744 seconds. Okay. Now, we've talked about significant figures. We should evaluate this to see if we need to round this answer or not. 12.4, the number we started with, that's a 3 significant figure measured number, so that would limit us to 3 significant figures here. 60 seconds in a minute, this is the definition of the relationship between minutes and seconds. So this is what we described earlier as an exact number. So neither of these numbers will limit significant figures as a result of a calculation. So they're both exact. So that means this 3 from our first piece of data is what will represent the right level of precision in our answer. So 744 is appropriate since that is also 3 significant figures. Okay. Now the second example here is doing the calculation in the other direction. If we start with 4,200 seconds, right? And we want to figure out how many minutes that is. Right? What I want to do here is cancel out seconds. So what I do in the second step here is cancel out seconds. So I'm looking for a conversion factor that I can put in here that would have seconds on the bottom, right? And that would either get me to my answer on top or get me closer to my answer. And we'll see that in some of the coming problems where we may need to do more than one step. If I can cancel out seconds, get to minutes, that's perfect because that's what I'm looking for. Right? And that would be the other conversion factor we described earlier. I want the minute part of the relationship on top. I want the second part on the bottom. Seconds again cancels out. Minutes is left over. Right? And now the 60 is on the bottom of the fraction. So that means I'm going to have to divide by 60 instead of multiply by 60. So 4,200 divided by 60 is 70. For my answer. Now in this case we started with a 2 significant figure number, right? So we have zeros on the right but no decimal, so just the 4 and the 2 are significant digits there. The relationship between minutes and seconds again is exact. So this should be a 2 significant figure 70, and to make that 2 significant figures we'd add the decimal to describe the fact that that 0 should also be a significant figure in this calculation, right? Or in that answer to that calculation. Okay, moving on to another example. If we start with this equality, 1 kilogram is equal to 2.205 pounds. So those are the same. We can make 2 conversion factors out of that piece of information. But one other thing to point out here, and this is common when we are crossing from one unit system to another, there's no defined relationship between kilogram and pounds. So this is not all an exact number. The way we usually define this type of relationship, we make one quantity exact, so the 1 kilogram here is considered exact, but then we would have to measure the other quantity, right? So if we had something that weighed exactly a kilogram, we'd have to put it on a scale to weigh it to figure out how many pounds it is. So in this case, this potentially could limit our number of significant figures. This we should treat as an exact number. Okay, 250 pounds, we want to figure out how many kilograms that is. So I'm going to start with 250 pounds here in my calculation, right? And like we talked about before, I want pounds to cancel out, so I'm going to want to put pounds on the bottom, right? And in this case, I can get 2 kilograms, so I can put that right on top and do this in just one step. Now, right up above, we said 1 kilogram is equal to 2.205 pounds. That means pounds here is going to cancel out. Kilograms is going to be left over. That's exactly what we wanted for our answer. And again, if we do the units and cancel them out, it's going to kind of lay out the math that we need to do, right? And again, this one may be a little more abstract than seconds and minutes, so it might be a little harder to know right off the bat that we would need a smaller number of kilograms than we had for pounds. Okay, if I do that division, I get 113.3786848. Now, not all of those numbers are going to be numbers that we should keep because of the significant figures. So 250 here, there is a decimal after the 0, so that's 3 significant figures. We said this is part exact, part measured, but it's 4 in the measured department. So that means 3 is what we should have in our answer. So I'll round that answer to 113 kilograms. Okay. Now, the second example here, we want to introduce something else new. 2,782 grams is the data we have to start with, and we're trying to go all the way to pounds. Now, just on the information we've talked about so far, we don't have exactly how many grams are in a pound. So what we might want to do in a case like this is do the problem in a couple of steps. Grams to kilograms is defined in the metric system. So in the first step here, I can cancel out grams and I can change my units to kilograms if I know that relationship. So 1 kilogram is equal to 1,000 grams. That would allow me to cancel out grams. Right here, my units would be kilograms. Okay. Now, that's not the answer I want for my problem, so I'm just going to add another step. But I still have units here to direct what I'm going to do. I want to cancel out that kilograms. I can't have that still be around when I get to my answer, which is supposed to be in pounds. But here I can use the same set of information we were given at the beginning of this kind of subsection. 2.205 pounds is equal to 1 kilogram. That allows me to cancel out kilograms. Right? And now I have the math laid out that will help me change this number into a representative of how many pounds this amount of material is. So I'm going to take 2,782, I'm going to divide by 1,000, that's on the bottom of the fraction, then I'm going to multiply by 2.205. And my calculator says 6.13431, 4 significant figures in our original data, exact number here. We said this one limits to 4 as well, so this should be 4 sig figs. So I'm going to round that to 6.134 pounds. Okay, let's stop there so the video doesn't get too long. We'll go on to the next page in the next video.